Hi everyone, this is lesson 5 of recurrence relations. Today we're going to look at setting up recurrence relations. These types of questions are really commonly asked in past papers. So sometimes you'll have to set up a recurrence relation before you can solve the problem. You tend to be able to tell if it's a recurrence relation question because it is quite wordy and there's usually quite a big context attached to it. So if we have a wee look at this example together. A greenhouse is initially heated to 10 degrees above the outside temperature. It loses 25% of its heat through the glass each hour. At the end of each hour, a heater boosts its temperature by 2 degrees. Form a recurrence relation to model the situation. So you can see there's quite a lot of information there, and what we have to do is go through the question and pull out the relevant information. One thing that jumps out to me is that it's saying it is initially heated to 10 degrees above the outside temperature. So if we're talking about initial values, that tells me that U0 must be 10. I should have written down the general form of a recurrence relation. So UN plus 1 equals AUN plus B. So if we get U0 is 10, it loses 25% of its heat through the glass each hour. So if we are losing 25%, what we have to do when we're writing a recurrence relation is think about what we're left with. So if we're losing 25%, that means we've got 75% left. And that 75% is what we're going to use in a recurrence relation. Now 75%, we have to write it as a decimal. Remember, 75% means 75 out of 100, and if we do the divide there, we just get 0.75. So we can write down that UN plus 1 equals 0.75 UN. So we've got most of our relation written, and if we just go through the question again, at the end of each hour, a heater boosts its temperature by 2 degrees. So it's losing 25% of its heat every hour, but every hour a heater's boosting its temperature by 2 degrees, so that tells me we are adding on 2 every hour. And that's our recurrence relation. The next part, what do you expect to happen over time? Now if they're asking you about what's happening in the long term, so they might use words like longer term or over time, etc. That's a big hint that they're wanting you to calculate the limit, and you've got to state the limit condition. So it's back to this star statement. So limit exists as our value of A, which is 0.75, is in between -1 and 1. So you must write that. Once you've written that, it's just on to calculating the limit. So limit is equal to B over 1 minus A. So our limit is going to be equal to 2 over 1 minus 0.75, which gives us 2 over 0.25, and that will come out as 8. So what we've got to do now is we've got to look at what this means in the context of our question. So it's saying, what do you expect to happen over time? Well, our limit's going to approach 8. That means that over time, the heat in the greenhouse is going to stabilise at 8 degrees. So we'll write a wee sentence to say that. So over time, the heat in the greenhouse will reach a limit of 8 degrees, and you can write i.e. it stabilises at 8 degrees. So it's always important there that you relate that back to the context of the question. So we'll go on and we'll look at another typical question. Again, you'll see it's pretty wordy. So a man decides to plant a number of fast-growing trees as a boundary between his property and the property of his next-door neighbour. He's been warned, however, by the local garden centre that during any year the trees are expected to increase in height by 0.4 metres. In response to this warning, he decides to trim off 15% of the height of the trees at the start of any year. Form a recurrence relation to model this situation. So again, the first thing to do is trawl through the question and pull out any information that's relevant. One thing that's jumping out to me is that the trees are going to increase in height by 0.4 metres. So that suggests to me that B is going to be 0.4. And the other thing that jumps out is he's trimming off 15%. So if he's trimming 15%, you've always got to think about what you're left with. That means you're left with 85%. So 85% as a decimal, 0.85. And we can put this into a recurrence relation. So their general form, un plus 1 equals AUN plus B. So we've got un plus 1 equals 0.85 un plus 0.4. And that's our recurrence relation there. So the second part, if he adopts a 15% pruning policy, to what height to 2 decimal places will he expect the trees to grow in the long run? So again, we've got this clue here. It's saying long run. That suggests to me that they're looking for the limit. If you're calculating a limit, you must always state the limit condition. So we'll just write this down, that a limit exists as, and we've got 0.85 this time, and that's obviously in between -1 and 1. So we'll work out our limit. Limit is equal to b over 1 minus a, so we've got 0.4 over 1 minus 0.85, which gives us 0.4 over 0.15, and that comes out as, we'll use a calculator for this one, so 0.4 divided by 0.15, and that comes out as 2.6 recurring. So we get 2.666 ... It's asking it for 2 decimal places, so that will be 2.67. So now we need to write a little sentence just to put it back into the context of the question. So if he adopts a 15% pruning policy, to what height will he expect the trees to grow in the long run? So we can write the trees will grow to a height of 2.67 metres in the long run. And that's us.